Question 1. When faced with a commercial design challenge where thermal bridging is causing significant heat loss through the building envelope, what is the most effective strategy an HVACR system designer should recommend to mitigate this issue without oversizing the mechanical equipment? A. Increase insulation thickness in all exterior walls only. B. Apply continuous insulation and use thermally broken structural components. C. Adjust equipment sizing using manual GA to compensate for envelope losses. D. Replace the HVAC system with a more efficient one rated SEER 21 or higher. Answer. Correct answer. B. Apply continuous insulation and use thermally broken structural components. Explanation. Thermal bridging occurs when conductive materials allow heat to bypass insulation layers, commonly through structural members. HRConquer 90.1 and I require designers to address thermal bridging by promoting continuous insulation and thermally broken components. Simply increasing equipment size, C, or insulation alone, A, ignores the root problem. Efficiency upgrades, D, improve performance but do not eliminate conductive losses. By using thermally broken materials inside the building's envelope becomes more effective, reducing HVAC load and oversizing. This approach aligns with high-performance building design per HRConquer Advanced Energy Design Guides. Question 2. As demonstrated by large office buildings in mixed humid climates, which HVAC system type offers the best flexibility for simultaneous heating and cooling, energy savings, and individual zone control without extensive ductwork? A. Single zone rooftop units with economizers. B. Constant volume systems with reheat coils. C. Variable refrigerant flow (ERF) systems with heat recovery. D. Split system heat pumps in each office space. Answer. Correct answer. C. Variable refrigerant flow (ERF) systems with heat recovery. Explanation. ERF systems provide simultaneous heating and cooling across multiple zones using a common refrigerant loop, offering superior flexibility and efficiency. According to HRConquer 15 and 90.1, ERF with heat recovery enables energy transfer between zones. Ideal for variable thermal demands in office settings. Option B. Wastes energy due to constant volume airflow. A. Lacks zonal control and often underperforms in part load conditions. D. Is viable in smaller spaces but not scalable for large buildings. ERF also reduces ductwork and associated losses, contributing to LEED credits for energy optimization. Question 3. Given the circumstances that Alvarez is designing a hospital HVAC system in a coastal city with high ambient humidity, she notices that despite maintaining room temperature, patients are experiencing discomfort due to sticky air. What should she prioritize in her psychrometric design to correct this issue? Increase return air temperature to force more latent cooling. B. Install UV lamps in the air handler to improve air quality. C. Lower the supply air dew point to enhance dehumidification. D. Add additional outside air beyond HRConquer 62.1 requirements. Answer. Correct answer. C. Lower the supply air dew point to enhance dehumidification. Explanation. Latent heat control is key in humid environments. Lowering the supply air dew point, typically to 50 or below, improves moisture removal, directly increasing comfort. HRConquer 55 emphasizes that relative humidity between 30% and 60% is optimal for thermal comfort. A. May reduce latent removal. UV light. B. Address microbial growth but not humidity, increasing ventilation. D. Without energy recovery increases latent load. Dehumidification is best addressed through air handler design modifications. Coil selection, slower air velocities, or dedicated dehumidification units, while respecting psychrometric principles. Question 4. From the perspective of refrigerant piping in a large ERF system, what is the primary reason designers must carefully consider vertical lift and oil return paths in the piping layout? A. To minimize total installed pipe length and cost. B. To comply with building code spacing requirements. C. To ensure adequate oil return to the compressor during off cycles. D. To allow for maximum pressure drop in the suction line. Answer. Correct answer C. To ensure adequate oil return to the compressor during off cycles. Explanation: ERF systems rely on correct oil migration, especially in tall buildings. Improper slope, excessive vertical lift, or lack of traps can cause oil pooling, starving compressors and leading to failure. Per ASHRAE Handbook, refrigeration and manufacturer specs e.g. Daikin Mitsubishi piping design must ensure oil return during part load, off cycles. Options A and B are secondary to functional reliability. D is incorrect, as excessive suction pressure drop reduces system efficiency. Proper piping slope e.g. 1 bore per 10 feet and traps at vertical risers are essential for oil management. Question 5. To illustrate this point, Mr. Jamal is designing a system for a school near an industrial area. Occupants are reporting odors and respiratory irritation. IAC testing reveals high particulate and VOC levels. What modification to the existing system would most effectively address these pollutants and ensure compliance with ASHRAE 62.1a? Install economizer dampers for increased ventilation. B. Add MERV8 filters to all return air grills. C. Incorporate activated carbon filters and MERV13 filtration. D. Reduce outdoor air intake and increase recirculation. Answer. Correct answer C. Incorporate activated carbon filters and MERV13 filtration. Explanation: ASHRAE 62.1 mandates minimum ventilation and filtration standards. MERV13 filters effectively remove fine particulates PM.5, while activated carbon captures VOCs and odors. Common in industrial zones. A. May worsen indoor air if outdoor air is contaminated. MERV8 B is insufficient for VOCs. D. Violates fresher air requirements and exacerbates IAC issues. Proper IAC design incorporates source control, filtration, and ventilation strategies per EPA IAC tools for schools and Leader V standards for enhanced IAC. Question 6. By evaluating a design scenario where a commercial building uses long duct runs with multiple branches, which duct sizing method offers the best compromise between efficiency, simplicity, and low noise levels? A. Equal friction method. B. Static regain method. C. Velocity reduction method. D. Constant velocity method. Answer. Correct answer A. Equal friction method. Explanation: equal friction balances pressure drop per 100 feet across the system, simplifying duct sizing and ensuring relatively quiet operation. It's recommended by a CAM Manual D and SMACNA guidelines for many commercial and residential applications. Static regain B offers better energy balance but is complex. Velocity reduction C can lead to oversizing downstream. Constant velocity D result high fan energy usage. Equal friction ensures system balance without excessive pressure drop, suitable for systems where balancing dampers are used. Question 7. Across different scenarios, is Patel notices a Manual J calculations for a residential project indicate a higher than expected latent load due to high infiltration rates. Which adjustment will most effectively reduce the latent load before selecting equipment? A. Increase ceiling insulation to R49. B. Add a whole house dehumidifier. C. Improve air sealing to reduce infiltration. D. Install a larger HVAC system with higher CO rating. Answer. Correct answer C. Improve air sealing to reduce infiltration. Explanation: infiltration brings unconditioned, humid air into the envelope, significantly increasing latent loads. Air sealing, via caulking, weather stripping, and envelope integrity, directly reduces moisture load as per a CAM Manual J and Energy Star Homes program. A. Helps sensible, not latent loads. B. Treats the symptom, not the source. D. Leads to oversizing and short cycling, worsening humidity control. Air sealing aligns with building science and energy code. C. G. For envelope performance and load control. Question 8. With the advent of variable speed compressors in DX systems, how has the thermodynamic performance of the vapor compression cycle changed compared to fixed speed systems in terms of efficiency and capacity modulation? A. Performance is similar but reliability is reduced. B. Efficiency drops due to lower compression ratios. C. Capacity modulation allows better part load performance. D. Cycle times are longer, leading to more wear. Answer. Correct answer C. Capacity modulation allows better part load performance. Explanation: Variable speed compressors adjust RPM based on demand, maintaining optimal compression ratio and improving ICAP at part load conditions. Those studies show 2.30% energy savings in residential and light commercial applications. An ASHRAE standard 90.1 recognizes variable speed technology as a path to compliance. Options A, B, and D misrepresent variable speed benefits. Improved humidity control, quieter operation, and enhanced comfort are well documented, especially in Energy Star rated systems. Question 9. In light of recent developments in energy recovery technologies, what is the principal advantage of using an enthalpy-based energy recovery ventilator over a sensible-only heat exchanger in a humid climate? A. Sensible-only exchangers remove more heat than ERVs. B. ERVs transfer both latent and sensible energy, reducing cooling loads. C. ERVs operate at low pressure drops across all flows. D. Sensible systems are required by ASHRAE 62.2 in all humid climates. Answer. Correct answer. B. ERVs transfer both latent and sensible energy, reducing cooling loads. Explanation. ERVs exchange moisture and heat, lowering the enthalpy of incoming air. This is crucial in humid climates where latent load dominates. ASHRAE 62.1 allows ERVs as energy-saving ventilation strategies, and ASHRAE 90.1 encourages their use for large systems. Sensible-only units AD don't reduce latent load. C is incorrect as ERVs may have high pressure drops due to moisture exchange media. ERVs contribute toward LEED credits for energy performance and improved DIAC. Question 10. To what extent does poor insulation continuity across the building envelope affect HVAC system performance and sizing? A. It leads to excessive internal humidity levels. B. It causes unpredictable infiltration rates. C. It results in higher cooling and heating loads. D. It improves system efficiency due to faster temperature changes. Answer. Correct answer. C. It results in higher cooling and heating loads. Explanation. Insulation discontinuity increases thermal transfer, creating hot-cold spots and increasing HVAC demand. Per icon ASHRAE 90.1. Thermal envelope integrity is critical to right-sizing systems. They and B are side effects but not primary impacts. D is incorrect. Rapid temperature shifts force short cycling. Air barriers and continuous insulation reduce thermal bridging and support proper HVAC sizing per ICAM Manual J and ASHRAE fundamentals, leading to better comfort and energy savings. Question 11. The underlying principle of zoning strategies is being evaluated by Tran, who is designing an HVACR system for a high-end retail facility with varying occupancy patterns, heat gains, and interior finishes. She proposes a variable air volume system with multiple thermostatically controlled zones. However, the client asks whether separate duct systems per zone would be better. What is the most critical technical justification for sticking with zoning? A. It eliminates the need for balancing dampers. B. It minimizes energy consumption by reducing air volume. C. It allows for independent control of each compressor. D. It complies automatically with ASHRAE 90.1. Answer. Correct answer. B. It minimizes energy consumption by reducing air volume. Explanation. VAV systems are designed to modulate airflow to match zone loads, which leads to significant energy savings, especially in part load conditions. This is supported by ASHRAE 90.1 and DOE energy modeling data. Unlike multi-duct systems, expensive and spatially restrictive, VAV achieves zone-level control efficiently. A is incorrect. Dampers are still needed. C applies more VRF or multi-split systems. D is misleading. Compliance depends on more than just system type. Zoning improves comfort and lowers fan energy, making it ideal for variable load spaces like retail. Question 12. When evaluating the merits of subcooling in the vapor compression cycle, what is the thermodynamic consequence of increasing subcooling at the condenser outlet? A. It decreases evaporator capacity by reducing flash gas. B. It increases overall system efficiency by raising enthalpy difference. C. It lowers compressor work by decreasing refrigerant mass flow. D. It shortens the superheat region and risks compressor floodback. Answer. Correct answer. B. It increases overall system efficiency by raising enthalpy difference. Explanation. Subcooling increases the amount of liquid refrigerant entering the expansion device, improving evaporator capacity by reducing flash gas. The greater the enthalpy difference between the evaporator inlet and outlet, the more heat is absorbed, enhancing system efficiency. COP. This aligns with ASHRAE Fundamentals thermodynamic cycle analysis. A is incorrect. It reduces flash gas, improving the evaporator use. C. Misunderstands mass flow continuity. D. Confuses subcooling with superheat. Subcooling doesn't increase floodback risk. Ideal subcooling is 1015, depending on system type. Question 13. Through careful analysis of the startup checklist for a chilled water system, HRConquer identifies inconsistent delta-T readings across multiple air handling units AHAS. Flow appears balanced, and valves respond to control signals. What should HRConquer investigate first to resolve the issue before suspecting sensor errors or design flaws? A. Check valve actuator calibration and stroke position. B. Increase pump speed to ensure full flow. C. Verify insulation continuity on chilled water lines. D. Bypass AHU coils to stabilize pressure. Answer. Correct answer A. Check valve actuator calibration and stroke position. Explanation. Miscalibrated actuators may not fully open or close, leading to inconsistent coil performance despite appearing functional. This often causes temperature mismatches and delta-T issues. Per ASHRAE Guideline 1.1 on commissioning, valve calibration is among the first checks during functional testing. B can mask issues but isn't root cause troubleshooting. Impacts thermal performance long-term, not immediate delta-T. D disrupts pressure relationships and control logic. Actuator verification is a foundational step in startup diagnostics. Question 14. From a practical standpoint, when interpreting mechanical drawings for a multi-story commercial HVACR design, what symbol or note would most likely indicate a change in duct static pressure requirement across floors? A. Duct transition detail callouts. B. Fan curve overlays. C. Static pressure setpoint flags on the riser diagram. D. Return grill sizing schedules. Answer. Correct answer C. Static pressure setpoint flags on the riser diagram. Explanation. Mechanical riser diagrams often include setpoint indicators showing where fan static pressure adjustments are required due to elevation changes or zoning shifts. This is common in valve systems or where booster fans are used. A. Indicates size shape changes, not pressure. B. Help in fan selection, not in spatial interpretation. D. Relates to terminal sizing, not system pressure. Accurate pressure zoning is critical per SMACMA duct design manual and must be reflected in both specifications and drawings. Question 15. While examining a three-phase motor installation for an air handling unit, which of the following wiring conditions is most likely to cause high current drawer motor overheating during operation? A. Slight phase voltage imbalance within 2%. B. Properly sized overload protection. C. Reversed rotation direction. D. One open leg single phasing. Answer. Correct answer D. One open leg single phasing. Explanation. Single phasing causes two windings to carry the full load, leading to excessive current draw and overheating. NEMA MG1 outlines motor protection against phase loss, and most VIV SDS or motor starters include phase loss detection for this reason. A is within acceptable ANSI limits. B protects against overload, not operational issues. C affects fan airflow but doesn't increase current. Recognizing and protecting against single phasing is essential in motor circuit design and fault response. Question 16. In response to a request for a high-performance HVAC design, ISTA Santos includes energy recovery, demand control, ventilation, and low-wattage ECM fans. However, the client's building has irregular occupancy patterns and uses natural daylighting extensively. To maximize energy performance under these conditions, what should ISTA Santos also recommend? A. Switch to constant volume reheat terminal boxes. B. Integrate BMS controlled occupancy sensors into the HVAC system. C. Reduce outside air to minimum ASHRAE 62.1 levels permanently. D. Replace all ductwork with plenum returns. Answer. Correct answer B. Integrate BMS controlled occupancy sensors into the HVAC system. Explanation. Occupancy-based control allows systems to ramp down ventilation and HVAC capacity when spaces are unoccupied. ASHRAE 90.1 encourages demand-controlled ventilation (DCV) and control integration to match occupancy fluctuations. A. Undermines VAV system efficiency. C. Violates IAC principles and adaptability. D. Affects acoustics and control zoning. BMS Plus sensors enable dynamic energy savings and better alignment with LEED and WELL building standards for energy and comfort. Question 17. The most significant aspect of ductborne noise control in office buildings involves which of the following strategies during the design phase? A. Minimizing duct length to reduce pressure drop. B. Specifying internally lined ducts near air handlers. C. Increasing diffuser count to reduce individual velocity. D. Installing fans with backward curved blades. Answer. Correct answer. B. Specifying internally lined ducts near air handlers. Explanation. Duct liners absorb sound generated by equipment and turbulent flow, especially near fan discharge. Smackner Sound and Vibration Guide recommends internal duct lining as an effective noise control method. A. May reduce fan noise indirectly but not sound propagation. C. Affects airflow distribution but not system noise. D. Can reduce blade noise but must be combined with system-level noise mitigation. Correctly placed acoustic treatment significantly improves speech privacy and occupant satisfaction. Question 18. One might argue that chilled water systems are preferable in large commercial buildings primarily because of which of the following system characteristics? A. High refrigerant charge per floor. B. Flexibility in part load control and thermal storage. C. No need for water treatment systems. D. Low first cost compared to DX systems. Answer. Correct answer. B. Flexibility in part load control and thermal storage. Explanation. Chilled water systems allow decoupling of cooling production and delivery. This enables thermal storage, e.g. isostratified tanks, and more efficient part load performance through variable flow control. ASHRAE 90.1 supports chilled water systems for large applications due to these advantages. A is false. Refrigerant is limited to chiller, not spread across floors. C is incorrect. Water treatment is critical. D is misleading. First cost is usually higher but offset by operating cost benefits. Question 19. During the process of finalizing a cost estimate for a LEED certified office retrofit, Delgado identifies that using ECM fans and energy recovery ventilators increases capital cost by 15%. However, she also models the 30% energy savings over 10 years. What should she present to the client to justify the upgrade? A. Payback period, life cycle cost, and utility rebate projections. B. RE performance certificates and manufacturer warranty details. C. CAM Manual J data supporting reduced equipment size. D. Initial capital cost comparison without considering energy rates. Answer. Correct answer. A. Payback period, life cycle cost, and utility rebate projections. Explanation. Energy-efficient upgrades must be justified through economic analysis tools like LCC, life cycle cost, NPV, net present value, and simple payback. ASHRAE 189.1 and LEED VV encourage total cost of ownership approaches. B. Supports reliability but not ROI. C. Helps sizing but not financial analysis. D. Omits critical long-term benefits. Many jurisdictions offer rebates for ECM and ERV installations, making the upgrade cost neutral or profitable within a few years. Question 20. By comparing refrigerant handling procedures for flammable refrigerants like R290 and mildly flammable R32, what is the most critical safety measure required during system service or charging operations? A. Ensure continuous leak monitoring with R400 TINA sensors. B. Use spark-proof tools and ventilated areas during service. C. Only charge systems in positive pressure mode. D. Disconnect all system wiring before evacuation. Answer. Correct answer. B. Use spark-proof tools and ventilated areas during service. Explanation. ASHRAE Standard 15.2 and IL 60335-240 outline strict guidelines for R32 and R290 refrigerants, spark-proof tools, grounded connections, and natural ventilation minimize ignition risk. A is irrelevant. R400 TINA is not flammable. C is inaccurate. Charge per manufacturer spec. D may be part of safety protocol but not unique to flammable refrigerants. Proper training, ventilation, and ignition prevention are essential for compliance with EPA Section 608 and fire codes e.g. NFPA 70. Question 21. During a commissioning process of a large rooftop unit, Mr. Wilson notices the compressor discharge temperature is unusually high despite normal suction and head pressures. Upon review, the expansion valve superheat is set too low. What is the most likely cause of the high discharge temperature, and what should Mr. Wilson do to correct it? A. Low superheat causes liquid refrigerant flooding the compressor, increasing discharge temperature. Increase superheat setting. B. Low superheat causes compressor overloading by vapor starvation. Reduce superheat further. C. Low superheat results in compressor running at part load. Increase refrigerant charge. D. Low superheat causes excessive compressor lubrication. Just oil level. Answer. Correct answer. A. Low superheat causes liquid refrigerant flooding the compressor, increasing discharge temperature. Increase superheat setting. Explanation. Low superheat means the evaporator outlet refrigerant is not fully vaporized. The liquid refrigerant entering the compressor causes slugging in excessive discharge temperatures, potentially damaging the compressor. ASHRAE Refrigeration Handbook advises setting superheat to 812 for safety and efficiency. Increasing superheat ensures all refrigerant vaporizes before compressor suction. Options B and C misunderstand superheat effects. D relate to oil, not superheat. Question 22. Considering the evidence from pressure loss calculations in chilled water systems, what is the primary consequence of undersized piping in long runs feeding multiple air handlers? A. Excessive pump energy usage due to higher friction losses. B. Reduced system pressure causing low velocity in pipes. C. Increased water temperature fluctuations leading to thermal shock. D. Reduced heat transfer efficiency at air handlers due to laminar flow. Answer. Correct answer. A. Excessive pump energy usage due to higher friction losses. Explanation. Undersized pipes increase fluid velocity, which exponentially increases friction loss, forcing pumps to work harder. ASHRAE Handbook. HVAC systems and equipment details friction loss formulas demonstrating this effect. B is incorrect. Pressure actually drops, but velocity increases. C is unrelated. Thermal shock depends on temperature changes, not piping size. D is wrong, as higher velocity generally promotes turbulent flow, improving heat transfer but increasing losses. Question 23. Newen is tasked with designing an HVAC system for a historic building with single-pane windows and minimal insulation. Considering this building's characteristics, what should be her primary design strategy to optimize occupant comfort and system efficiency? A. Oversize HVAC equipment to compensate for thermal losses. B. Incorporate improved air sealing and install storm windows to reduce infiltration. C. Use single large AHU to simplify control. D. Maximize ventilation rate per ASHRAE 62.1 without regard to envelope losses. Answer. Correct answer. B. Incorporate improved air sealing and install storm windows to reduce infiltration. Explanation. Improving envelope tightness and window performance reduces infiltration and heat loss, directly lowering HVAC load. ASHRAE 90.1 and IC stress air sealing is the most cost-effective measure for retrofits. Oversizing A. wastes energy and can cause humidity problems. Single AHU C. can create control issues in diverse zones. Maximizing ventilation. D. Without control and envelope losses increases load unnecessarily. Question 24. Given the circumstances of an HVAC motor experiencing frequent tripping, which of the following electrical issues is the most likely cause if line voltage is uneven but within plus 5%? A. Motor winding insulation failure. B. Minor voltage imbalance causing motor overheating. C. Phase reversal in motor wiring. D. Correctly sized circuit breaker. Answer. Correct answer. B. Minor voltage imbalance causing motor overheating. Explanation. Voltage imbalance as small as 3–5% can cause motors to draw excessive current, leading to overheating and premature failure. NEMA MG1 E standards. Insulation failure A is symptom, not cause. Phase reversal, C, affects motor rotation, not overheating. D is unrelated. Correct voltage monitoring and mitigation are essential to motor reliability and longevity. Question 25. While examining a hospital HVAC design, Mr. Lewis notes that the ventilation system includes 100% outside air with no energy recovery. The hospital is located in a cold climate with high heating demand. What modification should he recommend to balance HVAC and energy use? A. Add an enthalpy wheel energy recovery ventilator to reclaim heat and moisture. B. Reduce outdoor air intake below ASHRAE 62.1 minimums. C. Use heat pipes instead of ERVs to transfer sensible heat only. D. Install a recirculation system with filtration to reduce outside air. Answer. Correct answer A. Add an enthalpy wheel energy recovery ventilator to reclaim heat and moisture. Explanation. Hospitals require high ventilation rates per ASHRAE 170 and 62.1, but 100% OA without energy recovery results in high heating costs. ERVs recover both sensible and latent energy, reducing load while maintaining IAC, reducing OA. B. Risks IAC. Heat pipes. C. Only recover sensible heat. The moisture control is critical in cold climates. Recirculation. D. Conflicts with infection control standards. Question 26. To what degree does using inaccurate infiltration rates in manual J calculations affect HVAC system sizing and occupant comfort? A. Minor effect as infiltration rarely impacts load significantly. B. Leads to oversized equipment and increased short cycling. C. Results in undersized equipment unable to meet peak sensible loads. D. Infiltration does not impact latent load calculations. Answer. Correct answer. B. Leads to oversized equipment and increased short cycling. Explanation. Overestimating infiltration inflates the load, resulting in oversized equipment that cycles frequently, reducing efficiency and comfort. A cab manual J ResNet standards. They underestimates infiltration's importance. C is incorrect. Oversizing, not undersizing, is typical. D is false. Infiltration impacts latent and sensible loads. Accurate infiltration inputs are critical for right sizing. Question 27. During equipment selection for a multi-tenant office building, Roberts is debating between a single large chiller or multiple smaller chillers staged to match load. What is the primary advantage of multiple smaller chillers from a system design standpoint? A. Simplifies system controls and reduces commissioning time. B. Provides redundancy and improved part load efficiency. C. Decreases total refrigerant charge in the system. D. Minimizes first cost and installation complexity. Answer. Correct answer. B. Provides redundancy and improved part load efficiency. Explanation. Multiple chillers staged appropriately allow the system to operate near optimal efficiency over a wide load range, reducing energy use and providing backup if one unit fails. ASHRAE HVAC systems and equipment. A is incorrect. Controls become more complex. C may or may not be true. D is false. Multiple units usually increase initial cost and complexity. Question 20. When faced with fluctuating chilled water supply temperatures despite constant valve positions, what is the most logical first step in diagnosing the issue? A. Check for sensor calibration errors. B. Increase pump speed to stabilize flow. C. Replace the valve actuator. D. Reduce cooling tower fan speed. Answer. Correct answer. A. Check for sensor calibration errors. Explanation. Inaccurate temperature sensors can cause false readings leading to improper control actions. ASHRAE Guideline 1.1 stresses sensor calibration in troubleshooting. Increasing pump speed. B. Or replacing actuators. C. Are secondary steps after verifying measurement accuracy. Cooling tower fan speed. D. Impacts condenser water, not chilled water supply temperature directly. Question 29. Which of the following considerations is most critical when designing systems with refrigerants like R1234 if compared to traditional HFCS? A. Using standard copper tubing without additional precautions. B. Ensuring leak detection and minimizing refrigerant charge. C. Ignoring ASHRAE 15 requirements as these refrigerants are non-flammable. D. Maximizing refrigerant charge to improve capacity. Answer. Correct answer. B. Ensuring leak detection and minimizing refrigerant charge. Explanation: refrigerants often have mild flammability and require strict leak detection. ASHRAE 15.2 and minimizing charge to reduce risk and environmental impact. A. Ignores specific safety and compatibility requirements. C. Is false. ASHRAE 15 applies to all refrigerants. D. Conflicts with charge minimization goals in modern codes and regulations. Question 30. Mr. Ahmet is integrating a building management system (BMS) into a multi-zone HVAC system with VAV boxes. Several zones report inaccurate temperature control fluctuating by +4 deg. With BMS, features should be prioritized to improve temperature stability. Implementing PID control loops with adaptive tuning. B. Increasing fresh air damper minimum position. C. Disabling demand-controlled ventilation temporarily. D. Setting fixed supply air temperature set points for all zones. Answer. Correct answer A. Implementing PID control loops with adaptive tuning. Explanation: PID proportional integral derivative control with adaptive tuning allows the BMS to respond precisely to zone temperature changes, reducing oscillations and improving comfort. ASHRAE Guideline 13. Increasing damper minimum. B. Affects ventilation, not control stability. Disabling DSV. C. Reduces energy savings. Fixed SAT set points. D. Reduce system flexibility and efficiency.